Good evening, kids. I'm your Sridhar sir, physics lecturer. Today we are going to discuss the JEE Main 2025, 2nd April, the shift 1 or the morning shift. The total regarding the basic idea of the paper is like a paper is moderate and the formula based. Only two questions are tough. Remaining 23 questions they are just straightforward. Hmm. Those who are writing the 3rd, 4th April, the other like if, at least for tomorrow, those who are writing, no, go through all the formulas. Today night also, how much all possible, recollect all the formulas. Definitely, it will going to help you a lot. Fine. So we'll start the paper thing. Now the chapter, this particular question I picked up. Chapter name is the rotational motion, and the subtopic is problem based on the moment of inertia. Now let me read the question. The moment of inertia of a uniform rod of mass m and length L is alpha when rotated about axis passing through center perpendicular to length. If the rod is broken into equal halves and arranged as shown, then the moment of inertia about the given axis. They are given the diagram in the exam also. Looking at this diagram, we have to bring that basic formula. Well, so what is the question given? When the rod is about this axis, its moment of inertia about this vertical axis passing through its length. So here L by 2 rotating. How much it is? This moment of inertia is given this as ml square by 12. We know it. Now the same rod, it is cut into 4 parts. L by 4, L by 4. What will be its moment of inertia? First of individual rod will calculate. I dash moment of inertia of this part. This should be equal to like its mass, how much will become? M by 4. Mass of each part will be m by 4. So the formula will be m by 4. L by 4 whole square by 3. ml square by 3 is the formula. There is a mass of one part, quarter part. About axis passing through one end it is. So this will become ml square 3 into 64. We'll keep as it is. This is the formula. Now what is the total moment of inertia of system will be 4 I dash. Why 4? Because 4 such rods are there. So this will become 4 into ml square 3 into 64. ml square 16 will come. So this will become ml square by 48. But we have to express in terms of alpha. So this will become ml square 12 into 4. 12 4 is 48. So this will become how much? Alpha by 4. There is a moment of inertia of this system. Everything this within 2 minutes you should solve. You have to put effort, the fast solving calculations. Then, so we'll take the next question. We have the next question. The chapter name is Moving Charges and Magnetism. There's a chapter. Okay, fine. Then he is asking find the ratio of magnetic field at the center of, and the subtopic name is Biot-Savart law. Find the ratio of magnetic field at the center of circular coil to that at a distance 3r by 4 from the center of the axis of the coil. So we have to directly take help of the basic Biot-Savart law. So if this is the ring, rough diagram, this axis. Let this be radius r at a distance x is how much? 3r by 4. A current I is flowing. Then is asking ratio of magnetic field at the center of circular coil to at a point 3r by 4. What is the magnet ray B1 by B2? What is the magnetic field at the center? Mu naught I by 2r. What is the magnetic field at a distance on the axis? Will be 2 x square r square to the power of 3 by 2. This is our basic formula. Mu naught I will cancel out. Mu naught I will cancel out. This will become 2 x square r square to the power of 3 by 2. This will go to the numerator. This will become denominator will get 2 also get cancelled. Here r cube will get. What is the value of x? X will be 3r by 4 whole square r square to the power of 3 by 2 r cube. Fast calculations you have to do in exam. Here as a teacher explaining, I'm showing in detail. You must be ready with all these calculations. R cube will get cancelled out. So what will be left over will be 9 by 16 plus 1 to the power of 3 by 2. 9 by 9 plus 16, 25. 25 by 16 to the power of 3 by 2. 25. So this will become 5 square, 4 square to the power of 3 by 2. Square and 1 by 2 will cancel out. So 5 cube by 4 cube. 125 by 64. This will be your option. You must know this formula. Magnetic field at the center of the coil, magnetic field at a distance x on the axis of the coil. Then directly the Biot-Savart law, the formula. Very simple. You must remember formulas. You have to revise. You have to read many number of times. They'll become memory. Then once you know the theory and once you are good with the formulas, JEE means manageable. We have the next question based on the chapter oscillations. The chapter is based on the oscillations and the phase of SHM. The topic name is phase of SHM. The question is A2 SHMs are imposed on a particle moving along x-axis as x1 equal to a sine omega t, x2 equal to a sine omega t. Then is asking acceleration of particle given omega equal to phi. Now we have to get this one. So now it will be like first the particle will go for the resultant amplitude. Resultant amplitude will be given by, or the amplitude of each SHM will be a square only. 2AA. Then what is the phase angle between them? Will be cos pi by 3. This will become 2a square, 2a square. Cos 60 will be 1 by 2. Resultant amplitude is given by how much? A root 3. Then what is the phase angle? So actually it is like this, a simple one SHM like this. The other SHM is here. And the resultant SHM is here, makes an angle 30 degrees it should be. So what is your resultant SHM will be? Resultant SHM will be AR sine of omega t plus pi by 6. Why pi by 6? Because this phase angle. The resultant SHM will have phase angle of pi by 6. What is this? Will be a root 3 sine omega t plus pi by 6. We'll differentiate this. So I think we know the SHM will be, acceleration will be minus omega square. Then the acceleration of particle is asking to get the acceleration of particle. Minus omega square will be 25 a root 3 sine of this expression for acceleration. This will be your option. It's asking about the superposition of SHM, phase of SHM, or you can take the subtopic superposition of SHM. I'll take the next question. The next one we have the dual nature, chapter name, dual nature of matter and radiation, and the topic is photoelectric effect and F equal to QVB. magnetism also, and force on moving charge particle. These two ideas are uh, put here. So now this is there is a metal plate with work function phi. There is a metal plate, blue color one. Frequency of the incident light is how much? Nu. An electron is ejected normally from point A with maximum kinetic energy, or the kinetic energy of this is maximum. Then a magnetic field perpendicular to initial velocity and parallel to the metallic plate exists, uniform magnetic field throughout the path. The electron strikes the plate at B. Find the distance between point A and B. How the path of the particle? The path of the particle will be semicircle, because it is having huge width, no? Right, and this length will be radius R, and this will be R. Sir, how come it will move in that direction? So the velocity is like this. There's a velocity. Then the magnetic force should act upward. I change the magnetic field. So the magnetic field is upward. So we use the Fleming's left-hand rule. Magnetic field out of the plane, velocity. So in the electron, the force will be acting upward. This and when the electron is here, the force will be acting here. When the electron is here, it will have velocity v, and the force will be acting towards center. This will be the center of the circle, and it will be a semicircular path. In exam, you can't draw all these things. You have to directly imagine the situation. Okay, then the electron will come and strike the plate at B. Here, so it is ejected here. So this is the incident light. This incident light, it will come and strike at this point. It will move here. So this is the electron I am showing it. Okay, fine. It will go like this and will strike here. It's asking this distance AB. Distance AB is what? 2r. First, we'll calculate the kinetic energy. So the kinetic energy is given by K max equal to H nu minus phi. Then according to the magnetism, mv by qb. This you can also write 2mk. The momentum we can also write in terms of the kinetic energy by this formula. Then this will be 2m by qb. Kinetic energy will be h nu minus work function. Then the distance AB is how much? 2r. So this will become 2 times of 2m qb. This will be your answer. Photoelectric effect mixed with charge moving in a magnetic field. There's a basic formula, you know. There's a basic formula, you know, and there's a momentum in terms of kinetic energy. These ideas is what you should have. Now we'll take the next question. We have the next question based on the atoms. The topic is radius of hydrogen-like atoms. Then if you see the hydrogen atom, it will have 1 electron. Then if you go for helium plus, it will have 1 electron. Next again lithium double plus, it will have the charge of this nucleus. It will have 1 proton, Z1 equal to 1. It will have the 2 protons, Z2 equal to. It will have 3 protons, Z3 equal to 3. Then what is the formula for radius of the nth Bohr orbit? N square A naught by Z square. There's a formula which you should know for radius, for the speed, for the energy, all the formulas. Then A naught value will be 0.53 angstroms, which may not be needed now in this case. So he's asking the ratio of this one, ratio of hydrogen to that of helium plus to that of lithium double plus. This should be equal to 1, Z equal to 2. Okay, 2 square, this will be 4. This will be, or I'll write it, 2 square, 3 square. This will be 1 plus 4 plus 9. So this will be 36 plus 9 plus 4. So this will be 6 square, 3 square, 2 square. The option B will come. 60 is to 3 is to 2. Okay, fine. Some calculations are there. You can these are the formulas which you have to remember. Next, we have the chapter based on units and dimensions, and the subtopic in that chapter is KTG. So, what is the question? Find the dimensions of A by B square from the given formula P plus A by V square V minus B quotati, where the symbols have their usual meaning. Then, what is the basic idea? Like the dimensions of LHS should be equal to RHS. Is asking us to get the dimensions of A by V square. The dimensions of this should be the pressure. This bracket term P plus AB. So the dimensions of P should be equal to the dimensions of V square. So the dimensions of pressure is how much? Newton per meter square. So if you know directly the dimensions, well and good, or else you have to work out. So Newton will be again force will be mass. Directly I am writing the dimensions of the pressure will be m1 L minus 1 T minus 2. Or if you have forgotten this in exam, what is the pressure? Pressure will be Newton per meter square. Force by area. Force will be mass into acceleration. M1 acceleration L T minus 2. Area will be L square. So the dimensions will be M1 L minus 1 T minus 2. This should be equal to the dimensions of A. Volume square will be L cube square. So the dimensions of A will be M1 L to power of 5 T minus 2. The dimensions of B will be L cube. Because there's a volume, no? Volume will be L cube, it will be there. So now is asking A by B square, dimensions of A by B square. The dimensions of A are M1 L to power of 5 T minus 2. The dimensions of L square, this will be L cube square. So M1 L to power of minus 1 T minus 2. And this will be your option. So in exam, definitely the dimensions of pressure you don't remember, use this method. If you are able to remember, okay, fine, good. So the dimensions of this term, from the principle of homogeneity, the dimensions of this must be equal to this. The dimensions of this must be equal to this. From homogeneity principle idea. Principle of homogeneity. Let's start with the match the list 1 with the list 2. Is asking here coefficient of viscosity, strain, compressibility, gradient, and list 2 there is given this one. So this topic is based on the units and dimensions, and is asking about the viscosity, elasticity, compressibility means elasticity, and the pressure gradient. So directly the coefficient of viscosity formula, or the coefficient of viscosity formula, F equal to eta A dV by dx. If you know that you can manage. So this will be m1 L1 T minus 2 L square. This will be velocity L T minus 1. This will be n. This will be m1 Here L square, here L will cancel out. Here L to power of minus 1, T to power of minus 3. M1 L minus 1, T to power of minus 1. This will be the dimensions of quotient of viscosity. I think we have the this particular thing. Okay, fine. The first one is D. So will you work out other things? I think in exam you have to directly pick up. If I were in your position, I would have done that one. No need to solve further, because only first one will match with the D. The first one ABC does match. You need not to bother about these other things. You wind up the question here only. Sir, how come? Definitely, I think this is what we should save the time. Strain will not have any dimension. If you want to, can check it. Say strain, this will be A. Coefficient of viscosity is this one. So at least now you can confirm with this also. No need to check 3 and 4. You can save time. Got the idea, no? Huh? So we'll take the next question. The topic name is Kinematics. The chapter name is Kinematics, and the topic name is riverboat concept. Okay, fine. What we have here is there's a river bank. Then how the river is flowing? It is towards right. There's a direction of flow of river. We are assuming VR. Then some reference lines will choose for our convenient. Now, speed of boat is still water. What do you mean by still water? Velocity of boat with respect to river is called as still water. VBR only 27 kilometers per hour. So, but still water means with respect to river only, we'll call it as still water. And the velocity of river is how much? 9 kilometers per hour. And boat rows at an angle 150 degree with the river flow. The vector will be like this. VBR. This will be 90 plus 60 degrees. So this angle will be 60 degrees. And it takes 30 seconds to cross the river. It's asking to get the width of the river. He didn't say anything about where it is, where he will reach everything. Altogether is asking only he will start at a, whether is the shortest path, no information is there. So we'll do one thing. How to calculate the width of the river, we have to calculate. But he has given the time taken to cross the river. But he didn't say it is a shortest path or shortest time. Shortest time not possible, because it is up the river stream is fine. Shortest path may be possible, that we have to cross check. So now who will determine the time taken to cross the river? So we'll directly come for this one. Time taken to cross the river, W by velocity of boat with respect to ground along y-axis. I don't use any other thing. No. This will determine now velocity of boat with respect to river along y-axis equal to velocity of boat with respect to ground along y-axis, velocity of river with respect to ground along y-axis. The river is flowing along x-axis. What is the river flow? River flow is along x-axis. What is the velocity of the river along y-axis? This is nothing but Vrx. So what is Vry? Vry will be 0. So therefore now based on this, velocity of boat with respect to ground along y-axis should be equal to velocity of boat with respect to river along y-axis. What is the velocity of boat with respect to river? We know the formula. It's y component, VBR cos theta. Cos 60 degree. This time we know 30. Width of the river we don't know. VBR 27 kilometer, 5 by 18 cos 60, 1 by 2. Okay, with this width of the river will be 30 into 27, 5 by 18 into 12. Little bit calculations are there, little bit you have to be careful. This will be 15, this will be 6, this will be 9, 2, this will be 3, 3, and this will be 5 by 150 degree, 30 seconds, no? Now the calculations, this will be 10, 6, then further this will be 2, 9, 2 1 ja, 2 5 ja. So this will be 25, 225 by 2, 112.5 meter. This idea is very important. So sir, is it shortest path? You need not to bother. Is it a shortest time? No. We have to verify it here. So is it a the drift, is it 0 is what you have to verify. But the question is only asked this much. So you need this concept. Okay, kid, like there's a chapter name, rotational motion, the question, and the topic is torque and angular acceleration in the rotational motion chapter. Now let me read the question. The figure shows a disk of mass 5 kg and radius 10 having the axis fixed and free to rotate about its axis, this axis. A 2 kg block is suspended with the help of a string wound on the disk released from the angular velocity of this when the block moves by 0.2 meter. When this will descend by 0.2 meter, we have to calculate. I have got something answer like this. We'll check it how much we'll get. The block will descend. It will descend by distance h, or say x. Agree this. Now the decrease in potential G will be converted into translational kinetic energy and rotational kinetic energy. So here, applying conservation of mgx equal to mv square plus moment of inertia of the rotational kinetic energy of the disk. So as it is, radius is r, v equal to r omega, velocity of this point should be equal to velocity of this because the string will be taut, and net work done by tension will be 0 here. Fine, so that's why we are applying conservation of mechanical energy. What is v? V equal to r omega. We are asking the angular velocity of the disk. So we'll do one thing. V, what we can write, r omega. Moment of inertia of the disk, mr square by 2. This m and that m are different. We'll do one thing. I'll write m1. The mass of the block is m1. That of the disk, let it be m2. So this is again m1. We have to calculate this omega. We have to calculate this omega. So m1 is how much? Mass of the block 2. G value is 10 given. X is how much? 0.2. Equal to m1 will be 2 by 2. Radius will be 0.1 whole square omega square. M2 will be 5 by 2. Radius will be 0.1 whole square omega square. Solving this, we'll get expression for omega. This will be 4, 0.01 plus this will be 2.5, 0.25. 400 equal to 1 plus 25. 400 by 26 it will come. I missed one more 2 here. So here this will become 2. This will be the calculation 0.01, 5 by 4. 0.2 by 25 by 4 it is. This will become 25 by 4. Huge calculations will be there. This will become 29. Omega square will be 1600 by 29. Let me check the calculation. Here I think I missed it. 5 by 2 will be 0.05 by 4. So this will be how much it will be if you take 0.01 common, and it'll become 400 here. This will become 1 plus 5 by 4. So this will become 9 by 4. 9 by 4 or 1600 by 9. So omega will be 40 by 3 radians per second. Calculations, even teacher also will face problem. In fact, we will solve less, you have to solve more. So that's why the practice needed. All these things will come by hard work. When you solve the problems, then you get that ability to calculate very fast. We'll take the next question. This name of the chapter, Semiconductor Physics. The topic is Zener diode as an voltage regulator. So we have Zener diode. The figure shows an electric diode or nothing but Zener diode with voltage regulator. Voltage regulator circuit with a voltage with a Zener voltage. With a Zener voltage, Vz equals 30 volt. Find the current through the diode. These are some data. Find the current through the diode. We have to calculate this Zener current, Iz. This will be IL. First we'll calculate the source current. What is the drop? The drop here we know it. So how much of drop will be here? 30 volts. So the same 30 volt will drop here also. As these two are parallel, Vz, Vl must be equal to Vz equal to 30 volt. Apply Ohm's law here. We know the drop here because these two are parallel. These two are parallel. Fine. And the Zener diode will be used in the reverse diode, reverse bias mode only. So therefore, applying Ohm's law, Vl equal to IL into RL. Vl will be how much? 30. IL we don't know. RL will be how much? 5000. IL equal to 3 by 500. 6 milliampere. 0.66 will be 6 milliampere is the load current. Okay, agreed. We'll write the loop equation here. So the writing loop equation here to plus 90 minus 400 Is minus VL equal to 0. Here in this one. 90, 400 Is. VL equal to how much? VL equal to Vz, which is equal to 30. By 20. So this is equal to how much now? 3 by 2, 1.5 or 0.15 ampere or 150 milliampere. So how much of current is flowing here? 150 milliampere. How much of current here? 6 milliampere. So the remaining 144 milliampere should flow here. Applying the KCL at this point, you should apply KCL here. Is, Iz, and this IL. What is Is? Is will be 150 milliampere. Iz, IL will be 6 milliampere. Iz equal to 144 milliampere. This will be the Zener current. Fine. It's all about what is the Zener diode. It's all about the drop across the load will be that of the Zener diode, and applying the Ohm's law, then applying the KCL. These are the basic ideas. Okay, kids. We'll take the next question. Okay, kids. I have drawn the diagram. So this is the variation of intensity one. It's a little bit very good concept is there. Now what is this? The blue color one will show the variation of intensity due to diffraction due to single slit. Okay, fine. And the pattern will be symmetric. Everyone knows this one. So we are talking about the angular position of it. So what is the generalized formula for angular position? To predict the minima, this will be lambda by d. This will be 2 lambda by d. So you should remember this formula. The angular positions of minima are given by n lambda by d, where n will start with 1, 2, 3, 4. The angular position of maximas are given by 2n plus 1 lambda by 2d. And n will start with 1. So first maxima here will be 3 lambda by 2. Second maxima, okay, this will be 3 lambda by 2, 5 lambda by 2. Third will be 7 lambda by 2. Okay, fine. Second minima will be how much? 2 lambda by 2. Third maxima, so this will be 2n minus 1. Okay, so these are the formulas. The angular position of the maximas are given by this formula where n equal to 1, 2, 3, 4. So what is asking now? Theta 1. The angular position of the second minima. This is a second minima. So it will make an angle theta 1. The next third maxima. Third maxima is B3. So what are the angular positions of third maxima means put this will be n equal to 3. 3 to the 6 and n equal to 3. So it will be 6 minus 5 lambda, 7 lambda by 2d will come because it will start from here. 3 lambda by 2, 5 lambda by 2, 7 lambda by 2d. Okay, agreed. It will be like this, plus 1. Put n equal to 1, 3, n equal to 2, it will be 5, n equal to 3, it will be 7 lambda. This is a generalized formula. So this is for theta 2 here. So theta 1 plus theta 2 equal to 2 lambda by d, 7 lambda by 2d. This total angle is 30 degree. This only we are writing pi by 6. I think now solve it. 6 lambda by 2 pi will be 33 lambda by pi. These are formulas you should remember. You should know this is the concept. This is a theory. This is a topic based on the diffraction. Diffraction at single slit. This is the incident light. Formulas, we should be very good in this formula. If you know this formula, you can manage here. What are they? These are angular portions. Kids, we have this question based on the mechanical properties of matter. The topic name is elasticity. So here we'll start like this. A wire having length 2 meter having Young's modulus y, axial strain is and Poisson's ratio. Poisson's ratio actually out of syllabus, but still this question is manageable without this. Don't get confused here. Find the energy density. What is the formula for energy density? I think you know some formula. There's a very popular formula. Stress is squared by y. What is the sigma stress? Young's modulus, how you define stress by strain? Stress, so therefore we can write it as Young's modulus into strain. So this will become y strain square by 2. You know the Young's modulus given here. Strain they given. Substitute this, solve it, will get the required answer. Very simple. Unnecessary due to Poisson's ratio, don't get confused because in the energy density we don't need this. This is a question based on the classical magnetism. Characterization between permeability of vacuum mu naught, relative permeability mu r, permeability of medium, and magnetic susceptibility. These are the equations asked. So this will be just definition based. The permeability of medium is equal to how much? 1 plus susceptibility into mu naught, where this is a chi mu naught, and this will be that of the medium, and where mu will be equal to mu naught into mu r. So when you substitute this, 1 plus chi into mu naught equal to mu naught into mu r. So therefore 1 plus chi equal to mu r. Like this, the relationship between the relative permeability and susceptibility is this one. Permeability means it should be like that. There's the equation. I think this is also simple theoretical one, just formula based. Two uniformly charged sheets shown in figure. Find the net force on the charge cube placed symmetrical between the plates. So this is the topic. Gauss law, electrostatic Gauss law, and E bar due to the charged plates. E bar due to the charge plate. The question is based on that one. So here they have kept the point charge in between the charged plates. We have to calculate the force acting. Find the net force acting on the charge plate. This plate will produce the electric field E1. This will produce electric field E2. The net field will be towards right. You have to add up. The total field will be E1 plus E2. How much E1? Sigma by 2 epsilon naught. This will be 2 sigma by 2 epsilon naught. So this will be 3 sigma by 2 epsilon naught. Then the net electrostatic field is in this direction. Then the force acting will be F equal to Q into E. So Q 3 sigma by 2 epsilon naught, or 3 sigma Q by 2 epsilon. This is the force acting on this charge particle. And this will be your answer. Just simple idea. The electric field, you have to take the superposition, because due to the negative charge plate will be towards right, positive charge plate towards right. Add up both, we'll get the net field. And this charge particle is present in the net field. And what is the basic formula? F equal to QE. Very good, simple one. I'll take the next one. Okay, there's a question based on the fluid statics, the chapter fluid statics and hydrostatic force. Now we are going to discuss here. On the left hand side, we are having a liquid of density 1 gram per cubic centimeter. Here on the right hand side will be 1.5 gram per cubic centimeter. At a depth 3 meter, we have the window whose area of cross section 100 centimeters square. We have to calculate the force needed to hold the window. So what is a concrete wall represents two liquids of density, represents or divides as shown. This is a wall. This particular thing is a wall. This is a liquid of rho 1 density. This is a rho 2. There is a square window of area of 100 centimeters square. As we find the force exerted to hold the window, we have to calculate, because this liquid present on the left hand side will exert force. The liquid present on the right hand side will exert force. We have to calculate this force. So what is the force? dF1 should be equal to pressure P1 into area. This will be the rough diagram. We'll take it. There's a small strip we'll assume at a distance dy. This will be at a distance x. So this the width will be L. We'll write here. What is the area of this one will be? dA is equal to B into dy. What is the pressure at a depth? Will be rho 1 gy into B into dy. Rho 1 GB by dy. So what should be the force F1? The limit should be 3 to 4 meter. Now why 3 to 4? Because where the window is present at a depth from 3 meter to 4 meter. Okay, this will be the generalized formula. We'll get it. Rho 1 GB. This will become y square by 2, 3 to 4. This will be F1. So rho 1 GB to y square, 4 square minus 3 square. So rho 1 GB2, this will be 16 minus 9. 16 minus 9 will be 7. This is the total force. Similarly, what is F2? F2, you can solve it here only. Rho 2 GB by 2. The same thing. Okay, 7 rho 2 GB by 2. The difference of this force, which will be greater. Rho 2 will be greater than rho 1. So the net force needed will be F2 minus F1. 7 rho 2 GB by 2 minus 7 rho 1 GB by 2. 7 GB by 2 will be outside, rho 2 minus rho 1. B will be in terms of G to substitute 10 meter per second square. So solving this, everything will be 7, 10, width will be 1 by 2. Rho 2 will be density 1.5. This will be 1500. Gram. So here what we have to do is like a 1.5 gram per cc. This will be 1.5 by 1000. 1000 gram will become kg. This will become into 10 to power of 6 cubic centimeter. No, converting to cubic meter. This will become kg per cubic meter. So 1500 minus 1000. 35 into 500. 5 is 1700, 17,500 Newton. B is in centimeter square, 100 centimeter will be 1. Huh? Okay, kids, like we are converting this. I'll substitute here. So 35 into 5 will be 175. So 175 into 10 to the power of 2 Newton. Some data they should give us. So answer should be 175. Some 10 to the power of 2 should be utilized here. Answer should be force. Answer should be in terms of this one, 10 to the power of 2. Okay, this is also simple based on the fluid statics. Huh? If you know this F1, no need to calculate F2. Directly only you have to change the rho 2 value. No, that's what I did here. Okay? We'll take the next question. There's a topic based on ray optics. Huh? Refraction at spherical surface, just based on the small formula. Hmm? Now we have kept the real object. Here the ray of light will move from the rarer medium, will be incident on denser medium, and this is the normal. Then after refraction, okay, we'll assume that somewhere here it is. Okay, fine. So at point P it will undergo refraction, or say at M, there is a point P. So we have to calculate this object distance V. Or the formula like where the refracted is present in denser medium, mu 2 V minus mu 1 U equal to mu 2 minus mu 1 plus R. Why negative sign? Because towards right will be positive. You are measuring the object distance opposite to incident ray. So mu 2 will be how much? 1.5. V we don't know. Mu 1 is 1. Minus this will be at a distance 20 equal to mu 2 1.5 minus 1 plus 40. So 3 by 2V plus 1 by 20 plus 1 by 80. Three by V is equal to minus 30 by 400 V equal to this will be minus 40 centimeter. Where the image will be formed here. Okay, fine. They just need not to draw the ray diagram, just have an idea. Huh? So we'll take the next question. There's a topic based on the EM waves. Huh? It's telling that the wave is moving in a space where the wavefront of a wave is x plus y plus z equal to constant. Find the angle which direction of wave makes with x axis. It's asking alpha. So we know the direction cosine. What is the direction cosine? Will be x by root of x square plus y square plus z square. This will be 1 square, 1 square, 1 square, 1 by root 3. Because he has given x plus y plus z equal to constant. A simple, no concept, nothing, just the propagation constant here. The wave is, there's a wave, the direction in which the wave is propagating. This is propagation constant. He has given some wavefront like this. So this is a method. We take the next question. This will be about the electrostatics. The problem is based on the electrostatics Coulomb's law idea topic. 2 point charges Q and NQ are placed at distance L from each other. Then the electric field is 0 at. So we have the two charges here. One charge is Q, other is 9Q. These are the two different charges. Huh? Now where the electric field will be 0 is asking. Somewhere here, we'll take it far away from this. This will be x, this will be n minus x. The field will call this is 1, this is 2. Due to 1 it will be like this, due to 2 will be in this direction. And the net field should be 0, so E1 equal to E2. E1 will be how much due to this? Will be KQ by x square. Due to this it will be K9Q by, this is L minus x, no? This is distance. This distance is x. So KQ will get eliminated. So this will become x square equal to 9 L minus x whole square, or x equal to 3 L minus x, or x equal to 3L. X equal to 3L by 4 from charge Q. I think option it should be B. Huh? Okay, this is x equal to 3L by 4. Sorry, x equal to 3L by 4 from 9Q. Not there. 9Q. L by 4 will be Q. Option D only will come. 3L by 4 from here. So how much this length will be? L by 4. A simple formula based. Just electric field is a vector quantity. E1 and E2 should get nullified. We'll take the next question. The chapter based on the rotational motion, torque and equilibrium concept. Let me read the question. A square shaped lamina of mass 5 kg is at rest. Find the value of F. There's a lamina, it's at rest. Then net force, net torque should be 0 for equilibrium. For equilibrium 10 Newton, here 10 Newton towards right, 20 Newton towards right, 20 Newton should be towards left. Upward 20 Newton, downward 20 Newton. Net torque should also be 0. So therefore this F should be equal to how much? Definitely this, the value of F here. This F should be how much? Should be equal to 10 Newton. The reason for that, net torque should be 0. Net force should be 0. The torque set up about this point. Due to this 10 Newton, due to this equal and opposite. Due to this 10, due to this 10 Newton should be equal and opposite. Like that, net torque, net force should be 0. Then only equilibrium is possible. Rest means here equilibrium. Simple idea based. So therefore your answer will be option A. We'll take the next question. The figure shows the infinite plane having uniform charge density sigma. This is a charge sheet. A small charge particle is suspended having charge q by insulating thread. Find the sigma if the charge is in equilibrium. It will make an angle 45 degree. So here we have this angle 45 degree. Now what is this whole chapter? Gauss law. Again, E due to charge sheet and equilibrium concept. What are the forces acting? Tension, electrostatic force. Why electrostatic force? Because electrostatic field produced by the sheet, what is the direction of electrostatic field will be? In this direction. And I'll show that E bar, it will be easy for you to understand. What is this? These arrows, this will be the direction of E bar. Then the electro positive charge will experience force in the direction of field. This is QE. Tension, the string will act here. This is T. The weight, mg. Then this angle is 45 degree. Then T cos 45 degree will balance mg. T sin 45 will balance QE. We'll divide these two. Tan 45 degree is equal to QE by m. This will be 1. Tan 45 will be 1. QE by mg. So electrostatic field is equal to mg by charge q. After this, what is the electrostatic field produced by the charged disk? Sigma by 2 epsilon naught. There's a formula, you should know this one. Electric field produced by the non-conducting charge sheet, non-conducting charge sheet. So therefore this will be how much? Sigma equal to 2 mg epsilon naught by q. This is the answer. Okay, this is just based on the equilibrium. This is a chapter KDG and the degree of freedom. Let me read the question. Find the ratio of gamma equal to Cp by Cv for two gases having degree of freedom F equal to 3 and F equal to 5. The two gases are there. One gas is having degree of freedom 3, other is having degree of freedom 5. Degree of freedom means then Cv equal to Fr by 2, 3R by 2. This is some monoatomic gas. This is a diatomic gas. Then gamma, ratio of gamma for monoatomic gas equal to Cp by Cv for mono. Cp will be 5R by 2. Cv will be 3R by 2, will be 5 by 3. Gamma for diatomic, again Cp by Cv. Cp will be 7R by 2. Cv will be 5R by 2. By 5. So like this is asking the ratio of these two. Find the ratio of F equal to diode will be 7 by 21 by 25. I think I'm assuming a ratio of diatomic to monoatomic to diatomic will be 25 by 21. Diatomic to monoatomic will be 21 by 25. Okay, well, this will be our option. How the question was given, based on that the answer will come. Okay, I think I completed. Okay, let me check other questions. This question based on the kinematics 1D, uniform accelerated motion. A body travels with x distance with speed 5 meters per second, and the next distance 3x by 5 with speed v2. If the average speed is 50 by 7, find v2. So the basic condition is like this. it will cover a distance x with a speed how much? 5 meter per second. Next distance 3x by 5 with a speed v2. Definitely it will take some time t1, t2. How you define average speed? Total distance covered by total time taken. What is the average speed given? 50 by 7. 50 by 7 is the average speed. Then this will be 8x by 5. T1. T1 will be x by T1. This will be T2. So now T1 will be x by 5. T2 will be 3x by 5v2. X will get cancelled out. 50 by 7, 8 by 5 equal to here. 5 will be here. 5v2 will be here. v2 plus 1. So solving v2. So this will be 5 1 ja. This will be 5 5 get cancels here. 50, this will be 4. This will be 25 by 7, 4. v2 by v2 plus v1. 25 v2 plus 25 equal to 28 v2. v2 is equal to 25 by 3 meter per second. There's something question I gathered. It is of like this. Just based on the kinematics and motion in 1D. Uniform velocity motion. Let me take the next question, the last one. Okay, kids, like we have discussed the 2nd April shift 1 or the morning shift. JEE Mains 2025. The paper is better you can call like a easy or say moderate and purely formula based. 1-2 questions are a little bit lengthy and tough. The rest all everything are formula based. Those who are writing tomorrow exam, please focus more on the reading and the formula recollection. Just read and formula recollection. No need to do tough problems. You can see the type of paper what we are getting. Just you have to only go through the concept and the formulas. Because time is less, recollect as many formulas as possible. Okay, thank you for great support. We'll end up session. The second April's the shift 2 evening. I'll shortly upload it. Thank you one all. All the best for the coming shifts.